Well, hello. Today we're going to be talking about acceleration. Today you're going to learn about acceleration being a vector quantity, and we're also going to find acceleration is the slope of a velocity time graph. Um, acceleration. Acceleration is the change in velocity over time. Essentially, um, what that means is the change in velocity is going to be giving us then, as we've shown here, the change is the final minus the initial. That means change in velocity. There's some speed it's now going, there's a speed it was going, and you subtract them, that gives us the change in velocity. Acceleration uses velocity, which includes direction, so it is also a vector quantity. Acceleration is the change of velocity and the direction. You'd be accelerating north or accelerating south, accelerating forward, accelerating backwards. So that's what makes it a vector quantity. Okay, some examples. Boy's running 4.5 meters per second. He stops when his mother calls in 2 seconds. What is his acceleration? Well, the equation then is acceleration equals Vf minus Vi over t. So the velocity final is going to be 0 because he stops minus 4.5 over 2 seconds, and that gives us a negative 2.5 meters per second squared. Now, a couple things I want to talk about. Students always get hung up on this fact that it says what was his acceleration. Acceleration can be positive and it can be negative. If you have a negative acceleration, it means he's slowing down or decelerating. The negative implies the direction. That's what makes it a vector quantity. If it's positive, then you know it's positive acceleration. The person or the thing or the object is getting faster. Meters per second squared. Well, this is velocity over time. So velocity is meters per second, and we're dividing that by time, so we're dividing it by seconds. So really what we have here is meters per second divided by seconds, or seconds over 1. Well, in algebra, you learn to change this to a multiplication and flip the second fraction, which then gives us meters per second squared. So that's where I got my answer here of meters per second squared. Let's take a look at the next problem. Car is rolling 45 meters per second. It stops when a woman hits a parked car in 0.2 seconds. What was her acceleration? Well, again, I'm going to use the same equation from up here. The velocity final, again, is 0. They're going 45 meters per second. They stop in 0.2 seconds. So what's the acceleration? I get an answer of 225 meters per second squared. All right, right now we're going to talk about acceleration graphs because the equation is pretty easy for acceleration. So let's talk about graphs. When it comes to any graphs, there's really 3 things you can do with the graph to try to gather information from it. First of all, you can look at the x and y axes. All right, and you can say, okay, this is what I get from the x-axis, this is what I'm getting from the y-axis. And that's easy. Most students are really good at doing that. They've been doing that for a long time. In algebra, you start learning about slope, all right, where they have you, basically, you take the axes and you're going to divide. This is where we divide. Typically, we're going to take the y-axis and divide it by the x-axis. And we did that for distance and time, and that gave us speed. Well, what I want to introduce to you is this third concept, area. You can take your 2 axes and multiply them. We can take x times y, and that gives us some new area. Take your axes, your x-axis times your y-axis, it gives us some area. So by looking at the units, a lot of times this is going to give you something new. Okay, so let's look at an acceleration graph. All right. Well, from the equation, acceleration equals Vf. Acceleration equals Vf minus Vi over t. If you think about this being slope, the y's are on top and the x's are on bottom. So the y's have to be velocity or speed, and if what's on bottom is the x-axis or the x's, then this has to be time. So by looking at this, there's some things that we can start to find out. First of all, I can look at this in the x-axis. Tells me how long this object was moving. It was moving for 5 seconds. The y-axis, it's not giving me distance over here. It's telling me how fast this object was going. At 3 seconds, this object was going 10 meters per second. So right now I'm finding velocities from the y-axis. So first of all then, what happens when we divide the two axes? Well, that tells me if I take the y divided by the x, I get meters per second divided by seconds. Well, that's what we did earlier today, and that came out to a unit of meters per second squared. Henceforth, dividing is going to give us the slope, and when we find the slope, that means it is acceleration. This is tells us acceleration. So on a speed and time graph, these slopes, those slopes there, that's giving us acceleration. So the slope equals acceleration on a speed time graph. All right, how about now if I multiply? What do we get from the area? Well, I'm going to take meters per second and I'm going to multiply it by seconds. Well, the seconds cancel out and I get just meters. So that means when you take the area of something like this, what you're going to get then is distance. Not going to get distance on every graph. You get distance on an acceleration graph, or when you have speed and time. It's the area underneath the curve will give you the distance. And I'm going to show you some examples of this. Okay, let's look at some slopes by dividing it. All right. Well, if I wanted to find the slope here between 0 and 1, I would simply write down my order pairs just like we did for distance or for speed. And I get the order pair 1, 4. And I get to go to find the slope, and it would be 4 minus 0 over 1 minus 0. And I get a slope of 4 over 1. That's not the speed. It is the acceleration. The slope here is the acceleration. So on a speed time graph, my slope is the acceleration. The acceleration of this object between 0 and 1 seconds was 4 meters per second squared. Notice here, my slope is flat, which means it has no slope. So this had a slope or an acceleration of 0 meters per second. It doesn't mean it didn't go anywhere. It did not gain speed. It did not accelerate. So it stayed at 4 meters per second. Let's take a look at area. Well, to start off with, I want to find out the area between 0 and 1 second. So we said that would be giving me the distance. So I'm going to find the area underneath this curve. Well, what I have here is a triangle. It has a base of 1 and it goes up to 4. So for a triangle, the area of a triangle is base times height divided by 2. And what that gives me now is 1 times 4 divided by 2 tells me that this object, after 1 second, had gone a distance of 2 meters. Why? Because they accelerated at a rate of 4 meters per second. How about between 1 and 2 seconds? Well, here, this one right here happens to be a square. My base is still 1. My height is 4. So the area is going to be base times height. 4 times 1 means they want 4 meters from 1 to 2 seconds. How far have they gone all together? Well, this one had an area of 2. This one had an area of 4. So their total distance they've covered here is 6 meters. And that's all there is here to acceleration. Well, hey, I'm going to catch you guys on the flip side.